Hi everyone, so today we're going to be talking about lesson 5.4, the remainder and factor theorem. So let us start off with talking about the remainder theorem. Okay, what exactly is the remainder theorem? The remainder theorem states that f of a is equal to r. What do you mean by that, the remainder? Okay, what is a exactly? So if you remember this form, x minus a, this is the form of the divisor in synthetic division. You can never make or do synthetic division if you don't have the divisor in this form. Okay? Because you have to write a in the left corner in order to solve using synthetic division. Okay? So what exactly do we mean by f of a equals the remainder? Let us take, for example, that we have f of x is equal to x cubed plus 2x squared minus 3x plus 1. And you have to divide this by x plus 5. Okay? So you have to divide it by x plus 5. So we know that here a is negative 5. Why is that? Because x, the form is originally x minus a, right? Here it is x minus negative 5. So minus minus becomes positive. That's why it is x plus 5. So we will use this table. Write a in the left corner. So it is negative 5. Then we will write the coefficients of the terms. Okay? So here for the first term, x to the power of 3, it is 1. Then here 2, then negative 3, then 1. Okay? So now, for the first coefficient, we will just take it down as it is. And then we will multiply it by a, which is negative 5, which you will get negative 5. And then you add 2 plus negative 5, which is negative 3. Then you multiply negative 3 times negative 5, which will be 15. Then you add here, you will get 12. Then 12 times negative 5, again, you will get negative 60. And you add them, and you will get negative 59. So our remainder here is negative 59. Let me use a different color. Negative 59. Okay? Now let us see if this rule is in fact true. So we will write f of negative 5 equals, we will substitute x for negative 5. So negative 5 to the power of 3 plus 2 times negative 5 to the power of 2 minus 3 times negative 5 plus 1. So let us use the calculator and make sure that this in fact is true. So negative 5 cubed, which is negative 125, then plus 2 times 25, which is 50, then plus 15, then plus 1. And when you add these, you will get negative 25 plus 50 plus 15 plus 1. You will get negative 59. So is it true? Yes. Let us do another example. Let us do, for example, we have f of x equals x cubed minus 5x plus 2. Okay? And let's say it is also divided by x plus 5. The same exact thing. Okay? X plus 5. So synthetic division. So here, -5. Then here, we write 1 for the coefficient of x to the power of 3. Now, you should be careful of anything that looks like this, where you don't have the polynomial written in it is written in standard form, but it's not 3, 2, 1. No, it's like 3, then 1, or 4, then 1, or anything like that. It skips a one number in the sequence. So here, let us imagine as if this polynomial is written like this instead. X to the power of 3 plus 0, x to the power of 2 minus 5x plus 2. So this is how you want to try and visualize this polynomial in order to use synthetic division to solve it correctly. Because you cannot, for example, just write 1, then -5, then 2. That would be wrong. So what you have to do is write 1, then 0, -5, then 2. This will be the correct way to do it. Now we will do exactly what we did before. We will take 1 down, multiply it by a, so multiply it by -5, which will give you -5. Then you add them, you will get -5, then you multiply -5 by -5, you will get 25. You add, you will get 20. 20 times -5 is -100. You add these, you get -98. So this is our remainder for this example. Now let us see if this is correct. Now, let me just go back, and I'm going to ask you this question. Why do you think we use the remainder theorem? We use it to make sure that we have solved the divided the polynomial by the divisor correctly. Okay? So we use this theorem in order to make sure that our answer is correct. So now let us see if f of a is equal to -98. So we will write f of -5 is -5 to the power of 3 minus -5 times -5 plus 2, which will be, when you use the calculator, it will, let us first simplify, -125 plus 25 plus 2. So it will be, we know that this will, -125 plus 25 is -100, then plus 2 is -98. It doesn't really need a calculator, to be honest. So yet again, f of a is in fact equal to the remainder. Now let us look at the factor theorem. So the factor theorem. Okay? So the factor theorem states that the binomial x minus a is a factor of the polynomial f of x if and only if f of a is equal to 0. Which, what they mean by that is when the remainder is equal to 0. So let me write that down here. So it is, this theorem states that the binomial x minus a is a factor of the polynomial f of x if and only if f of a is equal to 0, meaning that the remainder is 0. Okay? Okay, so let's say we have x to the power of 3 minus x to the power of 2 minus 30x plus 72 divided by x plus 6. Okay? So let us use synthetic division to find the quotient. Okay, so a is -6. The coefficients are 1, -1, -30, and 72. Let us expand this. Okay, so first we take 1 down. 1 times -6, which is -6. Then you add these, you'll get -7. -7 times -6, which is 42. When you add these, you will get 12. Then 12 times -6, which is -72. Then you add these, you will get 0. Remember the last number, this number, is always the remainder, okay? So this is the remainder. So let us write the answer, which will be x to the power of what? To the power of 2. Why? Because the degree of our answer, when I say the degree of the polynomial, I mean the highest exponent or the greatest exponent is the highest exponent here -1, okay? And then you will continue writing it in standard form, so -7x plus 12, and the remainder is 0. Since the remainder is 0 and we're following the factor theorem, that means that x, the binomial x minus a, is a factor of the polynomial. So that means that the factors of the polynomial x squared minus 7x plus 12 include x plus 6. Okay? So that means that x plus 6 is a factor of x squared minus 7x plus 12. And the polynomial, this polynomial, is called the depressed polynomial. Okay? Why? Because its degree is 1 less than the degree of the original polynomial, which is this. Thank you everyone for watching this video. I hope you understood something about this lesson, and I'm going to be making another video about this lesson because this video was going to be too long. So if you have any questions, either you can email me at Educology.help at gmail.com, or just comment your question down below. And I hope you have a good day. Thank you.